morning, everyone. Good morning, everyone.
Good morning.
Good. Well, we got a good morning right there. I just want to, for the people in the booths in the back, yes, all of you people talking in the booths, keep it quiet back there. Wow, that actually worked. That's amazing. I hope everyone had a good time last night. I want to thank Qualcomm for a terrific party at the Science Museum last night. So today is Comic Book Hero Dress-Up Day. Good job, all of you.
Good job, Jim.
There we go. We got one. Yes, there we go. All right. I want to thank the judges who will make a quick decision for the single guy who actually did it. Sean Michael Kerner of eWeek, thank you. Stephen Von Nichols of ZDNet, and Kasia Lorenk of Tom's IT Pro. There's your guy right over there. Stephen, Michael, just turn around. You can just, there you go. Don't miss tonight's happy hour and booth crawl, which will start here at 5:30 p.m. This room will be closed between 4:30 and 5:30 for setup. So please come on right at 5:30. So we've got a great list of speakers this morning, all kinds of cool topics. What we really try and do at the Linux Foundation is, be a place where maintainers and kind of core developers from a wide variety of projects can come and meet at events like this and talk about hardcore technical projects and all the different things that you guys work on. But in addition to that, we pick as many sort of hot buzzwords as possible and try and work that into our content as well. Containers, Docker, IoT, you name it. And that's what we've done this morning. But seriously, we do have a great lineup of speakers for what are really the hottest topics in tech right now. I want to, in particular, before I introduce our speakers, thank the person who makes this content possible across all of our events. And I don't know if she is, there she is, Amanda McPherson, right over here. Getting the right kind of content, interesting topics, interesting speakers to come to these events is a lot of hard work, and Amanda really does well on that. So thanks again, Amanda, for that. Our first speaker this morning is someone who I've known for quite some time. He is the CTO of open source initiatives at Cisco. He leads open source programs across a multiple number of technologies and product lines at Cisco. He has had a long and illustrious career in tech. He was the first VP and product manager at ZenSource, founding member of the Java content and J2ME projects at Sun. And he is going to be talking to us about one of the hottest topics in tech today, which is the Internet of Things. So please welcome Michael Inescu, who will be talking about fog computing and the Internet of Things.
Good morning, everyone. It's great to be here in Chicago, the city where my brother went to school, the Windy City. I'm here to talk about the Internet of Things today. We'll talk a little bit about what it is, how did we get here, and where are we going with this thing. I think the future is all open. Before I start, I wanted to tell you a little story. The picture you're looking here, you're seeing on the left side, you see the primary mirror of the Keck Observatory in Hawaii. And this is probably the ultimate selfie that I ever took. They moved the entire mirror horizontally. We pointed to it, and we took this wonderful picture. I think this is one of the most amazing devices in the world. Definitely at the outer edge of things. I think in many ways, the environments and the people that actually deal with these devices probably tell the story. On the right side, there's a native Hawaiian. His name is Sniffy. I don't know if you see it there, but in his nose, there's 2 tubes for oxygen. There's not a lot of it at 14,000 feet over there, and this is the only man that stays 24 hours. He lives there. And he's actually showing us a fascinating actuator, one of the many, that operates this device. For those of you that don't know, This device here on the left, it's the laser, shoots about 600 kilometers in the sky. The mirror points towards the star and measures the wavefront interference. It eliminates the twinkle in the star to take these amazing, beautiful pictures. The best optical device in the world, better than the Hubble telescope. So this is sort of the upper end of the kinds of devices that are connected to the internet. What is IoT? There's many definitions. You see several on the slide. McKinsey's View, Accenture, SAP, Verizon, AT&T, ITU. They all talk about things, connectivity to the internet, a variety of ways to access it. The one definition that seems to be getting a lot of traction today is Gartner's. I don't necessarily agree with all of it. I think it's a popular definition. It's the network of physical objects access to the internet that contain embedded technology to sense or interact, internal states. The interesting thing is that everybody seems to agree that it is about connectivity, it is about new things, it is about machine-to-machine interaction, and most importantly, it's about new experiences, operating efficiencies, and new business models. At the end of the day, IoT is sort of the big frontier, not just for the internet, but for technology, particularly for Linux and open source. It brings about multiple hubs of innovation. So one way to look at this is that we see IoT as connected manufacturing, robotics in industries, connected energy. We see it as smart cities, connected home, a lot of things happening, including the projects here at the Linux Foundation, and of course, safety and security. The Internet of Things already arrived about 7 years ago. That's the inflection point we've already been through. There was a moment in history when the number of devices, shall we say connected devices that can access the Internet, exceeded the population in the world. It's about 6.5 billion of them. Today, the ratio of these devices to humans is about a little more than 2. In the next 5 years, we're going to reach about 50 billion on a conservative estimate. Other companies, other corporations, and analysts estimate the number to be more like 250 billion. The growth is phenomenal. 5 times faster than electricity or telephony. It's a few of the pictures here on the board. Everything from home sensors, entertainment, consumer devices, energy plant, factories, surveillance, instrumentation for manufacturing and robotics. A very exciting future. What this brings about is what we call new pins or places in the network. On the left side of the slide, you see the already known presence in data centers, in the enterprise or campus, in the branch office. Sometimes you hear this referred to as the carpeted space. Now we're going into the non-carpeted space. And in the case of the Hawaiian native, somewhere where very, very few people can actually live. This is an interesting picture. This is actually a ruggedized network device. We tested at Cisco. We want to make sure that it works in adverse environments, flood, rain, etc., fire. When I saw this picture, it was a little late. I told everyone that, this is going to be shown at LinuxCon. So these rubber duckies for a device that runs on Linux should have really been penguins. I'll promise to make the adjustments next time when we publish these slides. But seriously, what you see on the left is a router, in the middle is a switch over there. They're ruggedized, we test them. These are edge devices. I'll talk a little bit about the architecture and how they fit into the Internet of Things. The fascinating thing, and I always make a point of this, the most dominant project thing in all of these, by far, most promising as well, is Linux. These are all Linux devices. So what's driving this? What's causing all of this? Tremendous growth in these devices is the declining cost of compute. If you ask Gordon Moore, Gordon, how did you come up to this very interesting, phenomenal law called Moore's Law? He'll tell you it's not his, it's Carver-Mead. But anyway, according to Moore and Carver-Mead, right, we all know what happens. The size of the transistors, consequently, the cost of these devices. In the case of storage, it's a very, very fast exponential curve, faster than compute. Compute is it doubles every 18 months. So storage and compute accelerate at a much, much faster rate than bandwidth. Bandwidth, according to Jacob Nielsen, grows 50% every 2 years. So you can see here the exponential curves. What this really means is that the network scales very, very different than storage and compute. The sensors are going to grow in their abilities far beyond what we experience today. In the next 5 years, it's going to be just unbelievable. It's going to be daunting. It's very hard in today's terms to talk about we're going to squeeze Linux and all of the computation and the data in this edge device. It's a radically different world waiting for us out there to grab. Along with this, I'll talk about the concept many now know as data gravity. So I think we all understand this slide. There's 3 big waves. In the 70s and 80s, we went from centralized to decentralized, right? Mainframe to client server. In the sort of the mid-90s to the early 2000s, the model moved from decentralized to centralized, the rise of the cloud, outstanding on-demand optimization for operating these networks. We're right in the middle of this age. What we see with the Internet of Things is really the non-trivial extension of the cloud, where things are no longer centralized. There's massive decentralization going on because of the rising computation power at the edges and the lack of, or the impedance mismatch between the data produced at the edges and then the one that can come to the core. So just a quick snapshot, how bad is this tsunami wave? Every day we generate about 2 billion bytes. That's about 2 to the power of 18. That's more than the network can schlep or marshal or push from the edges to the core. And that number is rising. And if you believe that Moore's law is even more accelerated in storage, things are not going to get better. They're going to get worse. Well, that's a pessimist way of saying 90% of the world data was created in the last 2 years. That number is old. It should be more like 95. My favorite statistic on this is the one at the bottom. When you fly in a jet plane, each engine produces about 20 terabytes of data. You can't put that into a cloud for analysis. You have to do that on the engine. Not all of the data can come and be utilized or used during the flight. They use it for maintenance purposes later, so they save some of it, not all of it. And with 25,000, 28,000 flights per day, that number is just daunting. So I mentioned that I do like the Gartner definition of IoT. This is my personal view on this, and perhaps some of my colleagues at Cisco would share this as well. IoT equals small sensors plus big data plus action on that data, meaning analytics. So what we're seeing with IoT is 2 worlds colliding to create one. Networking is changing radically. The analytics are changing. The computation model is going to change dramatically. This is sort of the core slide, the money slide as I call it. You see here on the left the typical architecture that we have at the top, the servers and the storage, the core network, then there's the edge or access network, and all of these devices at the edge. Today, what's going on is we take this data, we rise it into the cloud, sort of like the way the fog would act. The dominating trend that we see is that this filtering analysis has to happen here. It cannot happen in the cloud. It's just impossible. It's too much data. So as a consequence, the compute model has changed. Why distributed analytics processing? You see several reasons in here. So now there's a change in where the computation happens. Very shortly, we're going to have a change in how that computation happens. The paradigm shifted. The essential difference between cloud compute and fog compute is this. What we do today is we capture the data, we store it, we put it in the cloud, we analyze it, we have massive data warehouses, analytics going on there, and then we make decisions to act on it. Eventually, we push notifications and actions to the devices. That was the past. That's the future. So data gravity means that the applications come to the data, not the data to the applications. Data is an interesting thing. It's very difficult, very expensive to move around. The applications will come to it and will come at the edges. So fog architecture. Fog is the non-trivial. So I need to underscore that it's not just a trivial extension of the cloud. It's a non-trivial extension of the cloud in the distributed, hierarchical organized platform where the internet meets the physical world at machine-to-machine scale. I think I'm going to skip this slide. What this talks about is the importance of leveraging information, so big data analytics. Information about data, smart things you can say about it at the edges so that you don't deal with all of the problem of schlepping that 2 exabytes of data every 24 hours. So as we move through time, here's a different way to say that. As you move through time, you have a very good knowledge of the achieved data that in the past you've analyzed, you've stored. It can make you or enable you to make smart decisions about data in the presence. The devices collect information in real time. We don't have enough time to move that data into the cloud. We're going to filter it. So the present has a very, very limited computational power or network access ability. We're going to have to make smart decisions about it, filter a lot of the data, jettison the rest. The stuff that we deemed essential or important for historical reasons or for justifying our actions at the edge will be moved up in the cloud and will coexist there. By the way, this, for those of you that you recognize, this is a sort of the machine learning diagram. The fancy word for that is neuromorphic. So we have the input coming in, and in parallel with you optimizing on how you're going to model. Is your model good enough to predict the right action? In real time, you actually have to take an action on that on the device. But in addition to that, you constantly look to improve your model. This is why we take advantage of the computational opportunity on these devices at the edge. Very, very exciting world we're going in. So, Internet of Things. This is a what-if slide. General Electric, I think, published this about a year and a half ago, sort of what if we deliver a 1% improvement, for instance, in aviation, commercial aviation, 1% of fuel savings. They spread this out over 15 years, $30 billion, and then they get into power, healthcare, retail, oil and gas, which, by the way, seem to be the interesting, what I call the hubs of innovation or verticals or business opportunities in the market. It's a tremendous world, the scale of which we think the cloud folks have experienced, the kind of scale that they do at Amazon, at Google, at the big private public clouds, that pales in comparison to this. That's going to be, IoT and M2M is going to be orders of magnitude bigger than that. Here's the story, the narrative on sort of a summary slide on the Internet of Things, the world of machines. Like its cloud predecessor, it will be mostly open source. If you look at what's in the cloud today, in fact, many would say that open source sort of, and cloud go hand in hand. One created the other. The devices, the core, if you remember the 4-tier architecture slide that I showed with core at the top, access, then gateway. The core, access, and gateway devices already are open source. In my company, I believe 80% of our revenue is based on products and services shipped with Linux. And I believe that number is not going down. That number is going to go up. The edge devices vary. They're all vectoring very, very fast in open source. The network, the core, the access, the gateway, it's all the internet, of course, based on open source and open standards. The edge, we're going to work our way through a consolidation of protocols, renewed emphasis on robustness. And the new applications and services, this is the big thing. This is where data gravity comes into play. The model tips on its head. And there will be a rise in the way we produce applications, where they execute, how they run, what do we do, and how do we make money with them. These are amazing devices indeed. I said at the beginning that beautiful mirror, the 36 hexagons with 6 actuators each that move 2,000 times per second with a precision of 1/1000th of an inch to remove that twinkle in the star. As we speak, it's pointed to the supermassive black hole in the center of the galaxy, the best hope for us to understand what's around us outside of Earth are those kinds of devices. Remember, I mentioned that is arguably perhaps not the most advanced device in the world. I'm not advocating that that be one of the T in IoT. I just wanted to give you an example of where we're going with things. This is a Large Hadron Collider. What you see on the left is essentially the channel through which the 27-kilometer thing through which the protons get accelerated. What you see on the right is where that thing goes in with a very, very large coil. In a couple of places, the sensors where the collision happens and you extract the data. I don't have a picture with that. It looks like the one on the left. That thing is running on Linux. I think all the people that ever contributed to the Linux kernel should be very proud of that. The advanced network, designed and operated by Caltech at CERN, which actually it's a beautiful place, right? I mean, this is where the World Wide Web was designed and created. It's running on Linux. The network is based on OpenFlow. They set every world record in data speeds, currently running at about 1 terabit per second. My prediction for Internet of Things, new IoT-specific service providers will emerge. That is, in my opinion, the biggest thing that we're experiencing, and it's just coming up now. All IoT software will be open source. Why? Open source equals credibility. It dominates development. There is no other way about it. And where is open source already in the Internet of Things? Everywhere. Thank you.
Nicely done. Thank you very much, Michael. So how many people here have heard of Docker? Has anybody not heard of Docker? Not a single person. That is great. Well, you will be happy to meet our next speaker. This whole Docker container thing I hear is a big deal. James is always droning on and on about it. Exactly. Our next speaker is actually the founder of Docker, and the creator of the Docker Open Source Initiative. So we are going to hear directly from the source. He is also a Forbes 30 Under 30 and Y Combinator alum, which really makes him younger, more successful, and better looking than me, which I think, Amanda, we have to work on our content committee here because that's unacceptable. We can't have people like this. But Solomon has served for 5 years as the CEO of .cloud, running all of their business operations, fundraising, product launches, until focusing entirely on Docker. and he will be speaking about containers this morning. So please welcome Solomon.
And keep on wishing.
Hey everyone. Well, thanks Jim for the intro. My name's Solomon. I'm the founder of Docker and a company called .cloud before that. So I heard Jim asked who knows about Docker, but I'm going to ask again because I didn't see the hands. Would you mind just showing me? All right. Okay, so most of you know about Docker. So today I want to talk about Docker, but more importantly, the underlying trend in software development and systems in general that is the reason why Docker exists, and the reasons why, the reasoning behind Docker, right? Our goals, our design philosophy, et cetera. So I have another show of hands to do. If you read this, which is the real quote from an email I got, could you raise your hand if you feel like this applies to you? All right. Yeah. So yeah, Docker is popular. It became really popular really fast. And that's a good thing, because I'm here, I get to talk to you about it. It's also, in a way, a problem, because most people today who are aware of Docker have not experienced it directly, I think. And as a result, they haven't been exposed to the design philosophy and really the reason Docker exists, right? So it's both a good and a bad thing. So I'm here to talk about, hopefully, the things that that you hear about less often about Docker, right? So I'm not going to talk about the shipping container analogy, because we've been very good at explaining that one, right? A standard unit of shipping something, that's very useful. But I want to go beyond that. Before I go any further, I just want to take this opportunity, since we're here at LinuxCon, first to say I'm really, really proud and honored to be here. And second, since I know a lot of Linux contributors and maintainers are in the building, to acknowledge the fact that Docker would not exist without this incredible foundation that we have that we're building on top of. And if you guys could join me in a round of applause for everyone who's built Linux. So yeah, I'm a big fan. So let's talk about this trend and the reasons behind Docker. But just in case you didn't follow the last developments, just to give a sense of what I mean by the internet won't shut up about it. Docker is very, very active. There's a lot of buzz around it. There's a lot of people contributing a lot of patches to it. There's about 500 contributors. We've received over 7,000 pull requests. There's 14,000 Dockerized apps, what we call Dockerized. In other words, an application that we know of that has been outfitted at the source code level to be automatically built into a Docker container. And the one that impresses me the most is that there's been 250 meetups in 90 cities, people getting together in real life to talk about Docker, show each other projects, hacks, et cetera. And this is a graph that the events team, the people who help organize meetups around the world, shared with me about how fast this happened, right? So just keep this in mind as we talk about everything else. This is something that happened very fast, and a lot of people are just incredibly excited about this project, and we're basically trying to keep up. This is another graphic that gives a sense of what's going on. This is a snapshot of all the different projects and organizations that we know of that are either building something on top of Docker or integrating with Docker very tightly. So you can see there is everything from platform as a service to continuous integration tools to Linux distributions, cluster management tools. I think there is 4 different talks today given by some of the people behind these projects. So if you want a different perspective, I encourage you guys to attend that. So the summary here is that Docker is very popular. It became very popular very fast, and we're not always sure why. I think that's the question that I get the most. So setting that aside, I want to talk about the underlying reason. And my personal theory about why Docker has become so popular so fast is that it was just in the right place at the right time for a trend that is much bigger than Docker, and that is very important, I think, for all of us. And it's a trend that has to do with how applications are built, right? So if you're writing software today, chances are this trend is important to you. And this is my best possible way of summarizing it. This is what users expect today, right? If you're using Gmail, using Uber, using anything that's online, as a consumer of software, you expect it to behave basically like the internet, right? You expect an application that is a service, that is just always there, it's always on, 24/7, it's globally available, right? From any kind of device, it's not attached to one machine. It works whether you're the first user or the 1 billionth user. Basically, it's undistinguishable from the internet, right? And if you ask a lot of people who use software every day, what's the difference exactly between Gmail and email and their other favorite online application, it becomes very difficult to explain the difference because really, increasingly, people don't want there to be a difference. They want the application to be like the internet. And that's a problem for developers because the internet is a very reliable thing and it works really well. And everyone else is here trying to make their application work on one machine still, right? So that's really the trend, right? I, the developer, need to create an application that runs like the internet. And to do that, I need to somehow decouple the application from the underlying machine, right? I can no longer hand the user a few bits and then they install those bits on one machine and then they're happy. Somehow the application has to be everywhere and nowhere, right? A machine dies, another machine can take its place. We're deploying to a new location in the world. Now the application is also there. All sorts of technical problems that have a solution, right? The technology exists to solve these problems, right? We know how to build distributed systems. And again, a lot of those solutions are built at the kernel level, at the very fundamental system level. And a lot of development teams around the world use those tools to produce kind of a solution to their problem, right? The problem is that everyone is kind of reinventing the wheel in their own way. And you have large web companies, for example, that have hundreds of engineers that's all they do. They build tools to make it easier to create these distributed applications, right? And as a result, there's a lot of waste, right? A lot of people are just reinventing the same tools over and over again, when really 90% of the time there's a standard set of components that could do, right? So that's really the problem, right? The trend, everyone is looking for this, a sort of a standardized way to build these distributed applications that, in a way that leverages the available system technologies, right? But packages them up in a way that is accessible to application developers. So really, that's the problem we're trying to solve. And the best way I could describe to you what we're trying to do with Docker is to provide this toolkit, right? To provide developers with a toolkit to build these distributed applications. And we want to do this in a very specific way because that's been done before. A lot of people are trying to do that. And that's precisely it. Developers are a very diverse group of people. And not everyone wants to build their applications the same way. And although there's a consensus that, okay, if I'm building an application that's going to be available online anyway, it needs to be this distributed system, really. But not everyone wants to build these distributed applications at the same pace, in the same way, right? I want to build this on my terms. Maybe I have an existing application. I built it in a very different way, and I know I need to transition it to this new model, but I can't just throw everything away right now, right? So really, that's the fundamental design decision that we made, is to, instead of providing a large monolithic thing that solves all of your problems end to end, but you have to buy into all of it right away, which means you have to throw away a lot of your existing tools. It's an all or nothing proposition. We went the opposite route. We try and continue to try to break down that toolkit into the smallest possible, the set of the smallest possible tools that can help you in different areas. And it's very important to us that you don't feel obligated to use all of it, right? So we spend a lot of time turning Docker into a good ingredient, right? And I'm going to go over a list of the different kinds of problems that we're approaching. But that's really, like, underlying all of this is this essential design philosophy that you should not be obligated to use all of it. And as a result, if you ask 10 different people what Docker is, they might give you 10 very different answers, right? I've heard that Docker is an LXC wrapper, right? I've heard that it's a packaging system, right? I've heard that it's a service discovery layer. I've heard all sorts of stuff. Well, that's a good thing. And again, remember this slide in the beginning about all these different projects that use Docker. They don't all use Docker in the same way, right? So what are those problems that we approach, that we try to solve? So the first one, and I guess this is where I talk about the shipping container after all, is how I package and distribute the components of my application, right? And remember, we're talking about building a distributed application, so there's lots of machines potentially. I don't know necessarily which machine will come next, right? And so as a developer, I need to produce, I still need to build and test and version and ship the bits that compose that are my software, the executable bits, and I want to do that in a way that the widest possible array of machines can run it, because I don't know in advance what will run it, right? And so that's really, I think, probably solving this problem is what Docker is best known for, because, again, the shipping container analogy, that works. But yeah, in a way, Docker is a packaging system of its own, right? It provides tools for specifying exactly from source how to create essentially a tarball, except it's a tarball with extra metadata and versioning and a particular way of transferring a new version with minimal overhead. I had to make a call, by the way, on the level of technical detail in this presentation. There's too much I want to talk to you about, so I will try to open a few discussions, and what I'm hoping is that after this talk, we can hang out and dive in. So forgive me if you want to hear more technical details and you don't hear them here. The second problem that we try to approach is the problem of a sandboxed runtime. And that's really coupled to the first, which is packaging and distribution. You can't really separate these. We try to separate as much as possible. So it's possible to use the packaging and distribution aspect of Docker without the runtime aspect. But this is where you see the largest multiplication effect of benefits if you use them together. Because you can package more bits in a more useful way if you can make assumptions about how those bits will be executed on the other side. So this is where, obviously, Docker leverages the features of the Linux kernel, C groups, namespaces, et cetera. And the idea is to provide the application developer with a contract, right? A known abstraction, so that the developer, when writing their application, can think, okay, this set of facts will always be true everywhere my application runs, because the Docker runtime will make sure that it's true, regardless of what's underneath. So this is where we define abstractions like exactly how are network resources exposed to the process, right? How do you set environment variable? How do you access the file system, et cetera? And again, we leverage underlying kernel primitives very heavily. Another problem that we're trying to solve with Docker, and that's I would say we're entering the territory of the next few months, right? The first two topics, that's really what we've been focusing on for the first year of Docker. And now, based on everything all the feedback that we got from everyone using Docker, including in production now, this is a list of the problems that we're focusing on now, right? So one very important problem is very quickly, if you're building a distributed application, you realize, okay, well, the entire application does not fit in one container. There's a database, there's a front end, there's a back end, there's lots and lots of components. And as you scale, one logical component will be made of multiple containers. So how these containers communicate with each other becomes very important. And again, we have the situation where the building blocks are basically there, right? Linux can do incredible things. You have incredible solutions out there for software-defined networking, The array of system technologies available is incredible, and that's kind of the problem from the developer's point of view. There's too many options, and there's no standardized way really for the application to consume those. The only reliable constructs I have are, okay, if I have an IP address, then I have IP connectivity, right? If I know which port to connect to, I can probably assume I can establish a TCP connection, right? But in an environment where you have potentially dozens or hundreds of individual components that need to know about each other and discover each other, and that topology is very dynamic, then that abstraction kind of isn't sufficient, right? So we spend a lot of time digesting all the different ways that people hack Docker today to do their plumbing, and then gradually what we do is we pull in the patterns, and then in the next revision of Docker we say, okay, this is the interface. And so if you're interested in the immediate future, one thing we're doing right now is piggybacking on DNS increasingly, so that using the Docker API, you can specify which container should talk to which, and then at the DNS level, that's made available to the application. And then if you need more capabilities, for example, watching for changes in the real time, we're exposing a custom API that, again, is optional. If you want to ignore it, your application can safely ignore it. Piggybacking on this topic of networking, pretty quickly you enter the wider topic of clustering and composition. The word orchestration is used a lot. We go back and forth on whether that word should be used, if it accurately describes a technical concept. But really, on the ground, when you're using Docker, pretty quickly you hit two fundamental problems. One is that you're not running, again, these containers on one machine at a time. You want a cluster of those machines, right? So I'm a developer. I want to run this logical unit, this logical software component, but I want it to be spread out across potentially hundreds or thousands of machines, right? So how do I do that? And the second problem is composition. How do I manipulate an application made of 10 logical components as a whole, right? How do I upgrade it? How do I add a component? How do I express the wiring? And so that is built on top of the networking construct I just talked about. And so, again, opening a thread here, this is a major focus of the next 3 or 4 releases of Docker. We are adding a lot of material to allow developers to specify their application as a whole, even if it's made of multiple containers, package that up as a whole, dispatch that on a group of machines, et cetera. So you expect to see a lot of that in the coming months. Another really important topic is identity and provenance, right? There's a lot of discussion going on right now about the ability basically to look at a given container and then trace it back to a developer, a build, basically be able to scan exactly what's inside that container and make a decision of trust, right? Do I know the origin of this container, and can I trust it? Can I trace it back to a specific Git hash, right? Can I trace it back to a specific set of system packages? And that requires additional hooks. And it requires things like the ability to sign containers and the ability to manage a key ring of keys, signing these containers, et cetera. This is all something that's being built right now. So in the 1.3 release, we're introducing, which is the September release, we're introducing the notion of an engine key pair. So every single Docker engine, whatever the machines it installed on, is bundled with a key management system, which is accessible through the Docker API. And the reason I'm opening this thread here is we are in kind of the early design phase of that, of what will be built on top of that. So I encourage you, if this is a topic that's interesting to you, to come see me or come in IRC and basically list your demands. Tell us exactly how you want to use this feature, how you want to sign and identify containers, and especially if you have an existing system to integrate with. And the last topic, which is kind of linked, is based on this information on identity, we want to allow really advanced and complex ways to express which container can do what in relation to which other resource in your system, right? So this is really, think of that as a stack that we're building up. Again, each of those components you can use independently of each other. And again, this is a topic that we're looking for as much input as possible on. So ideally, for the developer, the result is this. We've got this magical toolbox, and as a result, the process of building these applications is much, much easier. But if you want one piece, you can use it in isolation. And that's really the takeaway. Other than that, we're on IRC. This is really where the heart of the project is. I think there's over 1,000 people there now. It's very active. I'm proud to say people are very nice and welcoming. There is no IRC snark in there. So you guys know what I'm talking about. So I encourage you to come and talk about it. It's an ongoing process. We're really trying to catch up to the community in terms of quality and features. But yeah, we really want to make this a solid foundation. So I look forward to talking to. Thanks a lot.
Hold on one second. So are you going to be hanging around for a few?
Oh yeah,
all right.
I'm here all day.
I can't imagine that this crowd would have any kind of technical feedback or critique or any input for you at all. I can already see. Does anybody want to talk about Docker containers with this guy?
I'm actually staying all week in Chicago.
I'm raising hands. All right, so you're going to be around.
Yeah, and we're doing a lot of the core team is here. We're going to do a sort of a hack session at some point this week also. So by all means, get in touch, and the more critical you are, the better. That's how we improve the project.
This audience isn't going to be shy, so.
I know.
Thanks for coming.
Thank you.
All right. All right, our final speaker this morning is someone who has been around Linux for quite some time, from the very early days. Often you see him on panel discussions, interviewing Linus Torvalds and having discussions with him at many of our events. But Dirk Hohndel is also the chief open source technologist at Intel, where he works in the software and services group and focuses on Intel's use of open source technology and their contributions back to the community. Today, Dirk has come here to share with us how Intel is using open source to address the explosion of connected devices and the services and secure data that they demand. So please welcome Dirk Hohndel of Intel.
Come with me now. Come with me now.
Good morning. Good morning. It feels almost like talking at Starbucks. Oh, the only thing that's missing is a few baristas at the edge. Maybe we can add that for next year for a little more of the atmosphere. It's very nice. I know that many of you will have expected Imad Susu to stand here this morning. Unfortunately, one of his kids got rather sick and he had to cancel. And I find myself not for the first time in the interesting situation of learning yesterday that I'm giving a talk today. So there is one huge benefit to the way I do my talks. I have no slides, which makes the slide preparation process so much easier. Everyone loves to hear the slides. The slide-based presentation with a little dot in the corner says 1 of 245. It's my favorite presentations. So thank you, Jim. It's always a pleasure to be at the Linux Foundation events. I haven't been in Chicago in a long time, and when I packed my suitcase for this trip, I was expecting temperatures in the 90s and high humidity, and I wasn't expecting to be on stage. So thankfully, conferences like this come with a wardrobe, so being ready for this was easier than I thought, but I apologize for the pants. I was in Mexico last week, and it was really, really hot. Open source is all about people. And a lot of times, it seems to me that this gets forgotten when corporations give their presentations here and they talk about my corporation did this and the corporation did that and we, the corporation, contributed. And this always angers me because corporations don't write code. Maybe if you're talking proprietary software, that's how it feels to you. But of course, it's always the people. It is the individual developers. So who in this room is writing open source software every once in a while? Okay, it's you. You are the ones we're talking about. We're not talking about the Intels, the IBMs, the Ciscos. We're talking about you. And so when I talk about the contributions that Intel has made, I should always say the contributions that the people now working at Intel have made. And to me, this is important not to forget, because as this technology moves so quickly and as the buzzword of yesterday sounds kind of lame today, who remembers grid computing? That's weird. Yeah. And this was really, really hip. And I'm pretty sure in 2 years I will say, who remembers that cloud fad? That was strange. And this morning I found out that the cloud now comes down and turns into a fog. Okay. Okay. And of course, I will soon have to talk about IoT, because we all know if your project needs funding, it needs to be IoT. Works for me. I work now. I'm the chief IoT technologist. No problem. We can do this. So I always like to highlight a couple of things that we are working on right now, things that we think are cool and important. Sometimes they aren't necessarily what the journalists think is the latest hip thing. This time I think I'm pretty spot on, because I'll talk about something that's a little cloud and something that's a little IoT. I think. So first thing I want to talk about is OpenStack in the enterprise. So OpenStack, as we know, brings the idea of the ability to deploy solutions quickly in a very customizable, very easy accessible format. So instead of calling your IT department saying, I have the following requirements, I need a server who does that, and the IT department then calls the OEM and buys a server and tests the server, puts it in the rack, turns it on, connects it to the network, installs an OS, configures it. 6 weeks later, they say, oh, you can start deploying. We try to turn this into, I go to a web interface, I click on what I need, these services, this OS, this is my storage, my network, my bandwidth. Click, 2 minutes later, it runs. Very nice. So the question is, why do we need at the OpenStack level, why do we need a working group that is focused on bringing OpenStack into the enterprise? Because they should be all over this, right? They should be saying, oh, absolutely, let's deploy this. This is what I want. Well, turns out that while this sounds good and while this to most of us is intuitive and obvious, if you are in enterprise IT, there are a few questions that you may have left. And so when we started talking to enterprises, so why aren't you using OpenStack? Why isn't there a massive number of deployments of OpenStack in all of the large companies? It turns out that they actually do see some gaps, and they do see some things where OpenStack, the way it's implemented, what it implements today, the way it integrates into existing infrastructure, does not really meet what they expect. And so we, together with the OpenStack Foundation, started a working group to say, win the enterprise for OpenStack. And we split this into two halves, because we felt that on the one hand, there certainly are technical issues, big, small, perceived, real technical issues we needed to address. But on the other hand, we felt there really was this underlying perception issue. There was this dare I say, marketing side to it. And promise me you won't quote me, but I think marketing matters. It's important what people think. It's important to get the decision makers to understand that this is valuable. Now, as an engineer, I usually have my professional and required disdain for marketing people. But I'll admit here it's correct. It's very hard to go into an enterprise and talk to a CIO, talk to the deployment people, if they don't have that warm, fuzzy feeling that what you're going to do to them is good for them, it's not going to work. So we created a marketing working group that focused on, why are people not using OpenStack? Why are people not ready for OpenStack? And why do they think that OpenStack is not production ready? Quite interesting conversations, lots of learnings, and it folds directly into the technical side of the conversation. So the technical groups that work on addressing the issues that came out of this, taking use cases and saying, what is it that these CIOs want to do, these IT managers want to do, that today they can't do with OpenStack? And it's very much about integration into the existing deployment, upgrade management, change management infrastructure. It's integration into high availability infrastructure. It's integration into security infrastructure. A lot of what we in open source consider, you just put this on your server and it runs, doesn't work for a company that has 150, 200,000 servers that they want to manage. And they do this over all continents and 50 countries and 200 data centers. And so the technical working group that we created very much focused on answering these questions. And so we had a report out at the OpenStack board meeting a couple of weeks ago, and it was very interesting to see how quickly the technical project leads in OpenStack felt that the information that was given them here, this is specifically what is missing, this is what we need to be working on, how quickly that led to action and to projects and to new developments. And that brings us back to open source as people, right? So once people understand what needs to be done, once people see here are the technical gaps, here's where we need to go, it's fairly easy to start closing this gap. And hopefully a year from now, when we come back to LinuxCon, I believe in Seattle, we'll all talk about the successful enterprise deployments of OpenStack. Now, I said I'm going to try to cover all the important buzzwords, so let's switch to IoT. What is IoT? Michael gave a 3-paragraph definition with 2 pictures, and I didn't play a video, but I thought he would. IoT is whatever you want, because any device connected to the internet is, last time I checked, a thing. And so the internet was mostly made out of things before marketing people got hold of it. So the definition that I prefer to use is, shall we say, more on the broad spectrum, if it's connected to the internet, or if it can network, if it can communicate, and it can compute, it's most likely part of the Internet of Things, or it should be. 50 billion, 250 billion, really, who cares? The problem is that today, all these devices that are connected or could connect, they do so in weird and disconnected ways. So I took out my cell phone so I wouldn't destroy the audio quality. Who knows what this is? Well, who has good eyes and who knows what this is? Yeah, it's a Fitbit, exactly. So I have a Fitbit because everyone needs to know how few steps they take every day. And then it makes me climb up the stairs to my hotel room, and at the 11th floor I say, this was a really dumb idea. Fitbit talks via low power Bluetooth to my phone, which then hopefully talks to the server in the cloud, which then connects to the web app on my desktop, we're beginning to see a problem here. Because if instead of the Fitbit I have a Nike Fuel Band, it communicates over a different protocol to a different device, using a different connectivity technology, talking to a different backend and a different desktop application, and trying to make the two of them communicate and actually just collect my data and give it to me, that's nearly impossible. The huge challenge that we have is as we connect more and more devices to the internet and expect them to somehow work with each other, that everyone is inventing their own solution. Whether it's your fridge or your Apple TV or your TiVo or your Google Watch or your iPhone, they all could be talking to each other and do really useful stuff for you, but it's all different. So I have an Apple TV and a TiVo, and trying to figure out how I can rent a movie on the internet makes me want to go to the cinemas, seriously. So today, the premise of a lot of people seems to be, oh, the solution is you just connect to the cloud. Now, Michael gave very good reasons why that is a dumb idea, because your network's going to be even worse than the conference, and that's saying something. Sometimes the moments in the talks when you get applause are so telling. So these devices today, they connect via Wi-Fi, Bluetooth, Zigbee, ANT+, ERDA for the old people, NFC. There are a ton of interconnects. There are 10 times as many protocols spoken between them. And there is this walled garden mentality that a lot of companies have, and that more and more companies see as their way to get revenue in the end by capturing the user and forcing them to become the product. And let's take this the opposite way. If we don't want to give Google the data of which temperature my living room has, and if I don't want Apple to know how many steps I took and how many floors I climbed, I need to get to the point where these devices can talk to each other, where there is an actual Internet of Things that is not an Internet of Things to the cloud and someone gets my data and then maybe I get it back, but an Internet of Things that can work together. But to do that, we need to figure out how they actually can talk, how they can communicate. And so what is it that you want from a device that is truly just a device, that is not something you interact with? You want to discover it. You want to figure out it's there. And once you know that it's there, you want to know, what can I do with it? What are the actions I can take? So it's discovery and action. And you're a light bulb. What can I do with you? I can turn you on, off. Maybe I can change your color. You're a speaker. Oh, great. Maybe I can play music. Do you have a microphone? Awesome. We can play a speakerphone. That's the word I was looking for. You're a washing machine. Why do I want to talk to my washing machine? I don't know. Beats me. Maybe it interrupts my TV show when I need to switch from washer to dryer, and I think that would really piss me off. So basically what we want to do is we want to abstract out all the things that are proprietary, all the things that are trying to lock away the data from me, trying to make it hard for me to get to my data, trying to make it hard for me to discover things and take action. And so Intel and about a half dozen of companies have formed the Open Interconnect Consortium, and with the goal to say, let's do this the right way. Let's not add to the 50 standards that are out there yet another one that is, once again, just our way of doing things and trying to get people to do it with our technology and our tools. But let's create a truly open standard. So open standard means RAND-Z, right? Reasonable, non-discriminatory, and zero royalty. And let's go a step further. Let's take the standard and have a complete open source implementation of this. And I stress the word complete because we have so many standards out there that look beautiful until you try to implement them. And you realize, oh, but there are these 3 things where I need a proprietary plugin, where I need, to use this company's back-end server, otherwise it's not licensed to me. I need to give my data to this guy, otherwise that guy doesn't talk to me. No. An open source implementation of a truly open standard, a standard that does exactly what I just talked about. Discover what's out there, and then know how to take action. And abstracts this out completely from whatever communication layer you use, what protocol you use, who the product is from, and allows device to device to talk, compute to device to talk, and network to device to talk. So where are we? Well, we have an existing code base that needs a lot of vetting, and it needs to get to the point where we can say, okay, this covers everything that we have. So we are in the formation phase. We have decent draft standards that we are talking about, not something that we've published yet. We are in the early phases, and that's a good thing. Because whenever companies come to the market and say, oh, we're done, here's this beautiful open thing, and go consume it, my immediate answer is always, well, if it's open, then why haven't I heard about it in the alpha phase? Why didn't I get a release candidate? Why wasn't I asked during the beta phase what I thought about it? So here's what I ask you to do. Go to openinterconnect.org, look what we have there, connect to the organization, sign up, join, help, figure out what it is that this thing should do, how you would like to interact with the devices, and join our quest to create an IoT field that actually is controlled by real open source, open standard, by developers, by us. Thank you.
All right, we now have a break. Remember to stick around for the